So, hi guys, today I'm going to discuss the question, the big painting from Spoj. So basically it's just the advanced application of Rabin Karp algorithm. So in simple Rabin Karp algorithm, what you did was if you needed to find a pattern, suppose A in let's suppose B and C then 4 times A. So the answer for this would be this one comes here and then here. So the answer would be 3. So in the naive approach, what you could do is that you can just find the size of this pattern and just iterate over all the intervals. And you could do that in O of n, and then for every string matching with this and the part of here, you can just take an O of n extra time. So the algorithm would become O of n square. So with the help of Rabin Karp, you just hashed this string and every other string so that you could easily compare the string so that the matching part comes in O of 1 and hence whole algorithm becomes O of n. So basically this is the question here only. And here you are given this a big matrix, this one, and a smaller matrix, this one. And this is a pattern and this is the text. So now we need to apply the Rabin Karp here also, but it's just a modified version, or you can say a different implementation kind of thing. So suppose I can do that only with in basic Rabin Karp. What you did was, if you take a string, suppose like this: A B C D E F G H I J, nothing else, and you take a prime number, say 37. So what you did was you multiplied this character numbers with in the ASCII code minus 97 with the powers of primes, 37 to the power 0 and this 1, this 2. So basically what I would do here is that I would do the same thing. So here, there, whenever a value x comes, I would assign the prime number's power to that value, and if the value O comes, then I would just leave that. So for example, suppose OXXO type of thing is there. It's XXOOXOOX like this. So basically what I would do is that this 0, 1, 2, 3, 4, 4, 5, 6, 7, 8, 9, 10, 11. So this is the prime numbers power, and I would take this only whenever the value x comes. So I would take for value p raised to the power 1, p raised to the power 2, p raised to the power 4, 5, and p raised to the power 8 and 11. So I would store this in a 2D matrix. And then for the matching part, what I would do is that it's just a heck of implementation, but it's good way to understand it, and it can be used further also. So suppose the matrix is of 7 columns and there are 4 rows. Just for example, 10, 11, 12, 13, 14, 15, and so on. So what you would do is that this is a 3 cross 3 matrix. So what I can do is I would take this part, then at every iteration, I would move this box. So in the sliding window, that simple string part, you move the window. Here I would move what you can say a big square type of thing. So here, and then in the next iteration, my value would go on to this. So basically, I just need to convert that thing into here, and this could be done by similar approach that was used in the single string algorithm. So basically, suppose if your pattern was having a length of 4, so in that you would be having 0, 1, 2, 3 as the powers of 37. So, and now if you are considering the string from 3 to suppose 6, 3, 4, 5, 6. So what you would do is that you would multiply this whole pattern with the power of p raised to the power 3. So the whole string would become similar to this, and you could just simply compare their hash values, and if they come out to be equal, then the answer would be added to, then the answer would be incremented by 1, else you would just continue. So I would do here this only, but in a very modified way. So now let me show how would you do this. Let me just first erase it. Yeah. So my pattern was of dimensions 3 cross 3. So 0, 1, 2, 3, 4, 5, 6, 7, 8. And what was the text? Yeah. 7 columns and 4 rows. So I would now write down this only 0, 1, 2, 3. Just 1 second, please. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So suppose for now I just take this. So now I would take this three columns. Okay, so I need to anyhow convert this to this, so that every integer multiple is dead. What I can see is that here I am having 3, 4, 5. So if I take out common what p raised to the power 4 and multiply this p raised to the power 4 into this part, this whole part, then this would become equal, and 16 minus 8 here, 8. So if I now multiply p raised to the power 8 to this part, this whole part would become equal. So, and for every next iteration, that is for every square moving forward, just one right. Now, let me show you that also. Suppose I am moving one forward. So you can see that here I would need extra to multiply by p. Here also I would need p raised to the power 5. So I would need to multiply extra p. Here I would also need p raised to the power 9. So I would need to multiply extra p. So what I can say is that if I just take the first row, first square box, then for every right movement, I just need to multiply a value 37 into this whole value of string, which I would be a whole value of pattern, which I would be storing somewhere in any value. And then the next a bit tricky part comes when the string you are moving is down. Suppose now I am moving this string down. So 7, 8, 9, 14, 15, 16, 21, 22, 23. So now here what you need is, you need p raised to the power 7. Here what you need is p raised to the power 16 minus 5, 11. Then p raised to the power 23 minus 8, which is 15. So p raised to the power 15. So now you can see, well, now what you can see is that you here you was multiplying p raised to the power 0. And now you are multiplying p raised to the power 7. So you could see and see observation is that whenever you are moving one step downward, then you are multiplying the p raised to the power number of columns in the text matrix, number of columns in text matrix. So now here my whole algorithm gets completed, and after this I would just match this part with this, and if the answer would come out to be true, that is if the hashes match, then I would increment the counter, else I would just continue. So let me show you the code. It would be much more clearer when you see it. So here this is yeah. So here this the S and P is the pattern matrix, and this is the text matrix, which is S. So I am taking, this is just a simple input. Then this PR function is used to create the 2D prefix matrix of both the pattern and the string. So if any time the value X comes, I would store that in the sum value, then multiply the power of prime with 1 times more, and then would store that sum. So this pattern matrix would store my consecutive sum. So basically it's like this. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this value would store for 0, this value would store for 0 plus 1, this value would store for 0 plus 1 plus 2, this will store 0 plus 1 plus 2 plus 3, like this. But the text matrix is a bit different. It would just store the values. So if this comes out to be X, I would firstly store with this X, the value, the power of prime, and then I would just use the basic 2D prefix matrix storage method, which is generally used. So now this works just similar to the 2D prefix idea. So the segment of here would store this value, the segment here would store this value, and so on. So now this part gets completed. Now move on. Now let's move on to the calculation part. So here we have this B. Okay, so now let me tell you this. So basically here you move from p raised to the power 0 to p raised to the power 4, from p raised to the power 4 to p raised to the power 8. So how this p raised to the power 4 comes? So this basically comes from the number of columns in the text matrix, which was 7, minus the number of columns in the pattern matrix, which was 3. So this comes out to be 4, and this could be easily seen by just scribbling a bit on paper. So now this I just calculated, and this is the, if you don't know, this is the binary exponentiation function, which gives me the value of 37 raised to the power some x modulo 10 raised to the power 9 plus 7. And now this value is just used to calculate this. Okay. This is pattern matrix 0, 1, 2, 3, 4, 5, 6, 7, 8. So what I would do here is that I would multiply this whole value with p raised to the power 0, this whole value with p raised to the power 4, this whole value with p raised to the power 8, and so on. So it's for that only. I would calculate that value by just using the last element of that row minus the last element of the previous row, and then multiplying it by j, which is just that PHP par 0, 4, and 8 thing. And then at every iteration, I would just increase. So the PHP par 4 would become 8 and so on. So now this part gets completed. And now this row multiplication is just that thing. So basically, what I told here you is that whenever you moved one step for one step downward, for that you would need p raised to the power 7 thing. So that would be just the p raised to the power number of columns. So here that I am calculating. So now I'm just iterating over the whole text matrix and finding the prefix which I am requiring. So suppose if I was having 7 cross 4 matrix, then I would be requiring 3 cross 3 matrix every time. So at any index I comma j, I would choose this whole index, then delete the index minus 3 here and delete the index minus 3 here. But as this index would delete it 2 times, I would add this index once more. And here it's just the basic 2D method which is used. Okay. So now I would do this. If this value comes out to be equal to the pattern sum, then I would increase the answer. And every time, what I just told you earlier, that every time I need to multiply p to move to move the big square forward. So that I am doing here. And when this loop would get completed, then I would need to go downwards. So this would be just a row multiplication multiplying thing, that p raised to the power 7. And after every block, I would need to update my initial sum also. So that I'm doing here. So now it's just done. And if you want, you can have a look at code later. I would be attaching it to the video also. So hope you liked it and may you have learned something new. So thank you.